Here we go, some review for this is algebraic manipulation. That is probably the most retaken type of test that we have. Not saying this exact test, but I'm saying this category of test, algebraic manip, probably the hardest kind. All right, we have this on trig, which is probably the hardest topic that we have. All right, so don't underestimate this test. I don't think it's going to be like the hardest test ever. I'm just saying this has the potential to have lots of little picky stuff that can confuse you. All right, this is problem number 8 from the packet, and I just got it set up. And in the end, we had to do this. To get tangent of 71, you'll need a calculator. Your calculator will be handy on this test. All right, one kind of problem that I haven't spent much time talking about is in a common shape, like let's say a pentagon. You guys kind of know generally pentagons sort of look like that, right? All right. If I describe the radius of this pentagon, do you get that what I mean is that distance right there? Guys, don't talk it. All right, so I encourage you to pay attention to this and see if you can handle this problem. Do you get that if I draw this triangle right here, it is not an equilateral triangle, even though it may appear to be? All right. It's a triangle. And if I tell you that this radius, this distance here, which is not really a radius, but we call it a radius, is like 7, then you should be able to figure out how long this is. And you can't just say, oh, they look the same. They must be 7. It's not 7. All right. So what would I need? Remember how I was talking about before that you pretty much always come down to, we give you an angle and we give you a side. Well, what have I given you so far? I've given you a side. I must have somehow given you an angle, but I just didn't tell you how to figure it out. There you go, 360 divided by 5. If I just draw this out, it might understand that a little bit better. Because these 5 angles, 1, 2, 3, 4, 5, are all the same. And those 5 angles make up a total of 360. You take 360 divided by 5, you'd find out it was 72. The problem is that this triangle is not a right triangle. So if I decide to put a 72 in here and say that's 72, the problem is it's not a right triangle yet. How can you make it a right triangle? You might want to watch this. It's kind of important. Okay. I'd work on the assignment that's worth 15% and ignore the part that's on the test that's worth 85% if I were you. Anyway, so there is a right, excuse me, stop talking. I'll make it really clear. All right, this right here, that's a 90-degree angle. That's how I would make my right triangle. And then this little angle right here, it's not 72, it's half of 72. So it should be 36. So now all of a sudden I'm going to zoom in on that triangle. I've got a right triangle now, and it's got 36 here degrees, and it's got a radius, which is that kind of made up term, 7. And then I need to figure out this part right here. And then a lot of kids will get the answer and say, so the answer is this. But you got to really know what's the question. The question is, what's the perimeter of my pentagon? Okay, so it's really not hard once I figure out x is, but you're not done once you figure out x. Go ahead, use your calculator, use your brain, use some paper, whatever it takes. Figure out what x is, and then figure out the perimeter of my pentagon. Give you about 30 seconds. If you know what's going on, this should be easy for me. All right, for those that are stuck, here's how you would have started. You would have said, from this angle's perspective, I have the opposite, and I have, is that the hypotenuse? The 7 here? Yes, it is. So I go sine of 36 is opposite over hypotenuse. Because those are the sides I had, the opposite and the hypotenuse side. So I had to use sine. And then sine of 36, somebody help me with that. What's that, point something? 5, 8, 7, okay, x 7, and then I just have to multiply by 7, and I find x, and then that's like about half a centimeter. 4.1, thank you. And then a common mistake is to say the answer is 4.1, but that's 4.1, so then this distance here is also 4.1, which means each side is 8.2, and there's 5 sides. So 0.2 times 5, 17, is that right? No, 4, sorry. 8 times 5 is 40, and then you add the extra 0.2 times 5. 41, is that right? All right, good. So Do you get that essentially they just gave me the angle by saying it was a pentagon? That's a leap for a lot of kids. As soon as I say octagon, you're going to know what angle to figure out. How about a nonagon? Remember what that is? Nine-sided shape. How about a dodecagon? You know what that is? 12-sided shape. Yes. Yep. Because if we make the sides random lengths, it couldn't possibly be. But if it's a regular hexagon, we wouldn't do this one because I don't think many people know what it is. You know what a septagon is? 7. Yeah. All right. Could have used that, I guess. All right. Okay, you have to look at the triangle and figure out what you have. Since the triangle here, do you get that this is the right angle in that triangle? That's the key. Once you know that's the right angle in that triangle, and this is the little angle I'm working with, then I can tell for sure that it's opposite or adjacent or whatever. Okay. So there's a couple other problems I wanted to do because I think that they're going to help. We already did one at the beginning there where you have like a canyon here and then another part of the canyon here, and you were looking from here down to there, and you made your triangle that way. That's one way to do it. Okay, sometimes you're up in a plane and you're flying over the top of a couple things on the ground. Let's say there's something here and there's something here. Let's say that there's a, let's say this is in Minnetonka, and so this is over Lake Minnetonka. Okay, and you're flying in your ultralight up here. I do see guys doing that. And let's say they're looking down at this boat here. And it's going to be boat A. And there's another boat over here, boat B. And he wants to figure out how far apart they are. Okay. Let's say he knows from looking at his little instrument that his altitude, the altimeter, is telling him he's up 1,000 feet. Do you get how you start the triangle thing then? You get how there's two triangles. And if I want to find the distance between these two boats, I basically have to find, with this red triangle, I can find the black side. With this green triangle, the big green triangle, I can find the, let's say, the green side, the big green side. And then, yeah, subtract them tells you the difference from A to B. So I'll use like this purpley thing to be the distance between those two. So to find A to B, you take the black one and the green one, you subtract the big one minus the small one, and you get the pinky looking side from A to B. All right, and how would they tell you this part? Angle of depression again. So if they've said the angle of depression is like 4 degrees, if this is 4 degrees, then the rest of it would have to be 86, okay? And then that's a way of telling the green triangle's angle, and then the red triangle's angle, this distance from here to here might be, let's say, 30 degrees, and that leaves this as, oh, that's more like 60. Let's say that's 60 degrees, and this is more like 30. So they'll tell you the angles by using that angle of depression and angle of elevation thing. That's really crucial. Okay, last thought. They don't always tell you a side and an angle. Sometimes they tell you two sides. Sometimes they tell you to in a really obscure way, but they're really telling you two sides. Once they tell you two sides, you can figure out the what? The angle. So if you had it, let's say that you're a plane flying over the airport, and they say, hey, you know your altitude is 3,000 feet, and you know, using a device that you can look through and tells you a distance, you can tell the other side here is like looking off in the distance that your target, say it's a military situation, your target is, let's say, 8,000 feet away. You can figure out the angle of, this would be a tricky one, what if they asked you for the angle of depression? Well then, the angle of depression, you would first figure out this angle using trig, and then you'd have to subtract it from 90 and figure out that angle, which is angle of depression. Okay? Child's play. Clearly easy. Actually, it might be harder once the picture isn't drawn for you. That's the hard part. Once you get the triangle drawn, it's easy. All right, so let's figure out this angle right here. Call it theta. Would you please use a calculator and actually figure that out? If you don't know how to do it, we should make sure you know that now so you can practice more tonight. Figure out theta. Got an answer or a question? Okay, hold that thought for a second. Still see a lot of people typing. If you aren't using inverse trig, you're not doing this right. You might start by setting it up with regular trig. You could say, okay, what do I have? From this angle's perspective, that's the adjacent, that's the hypotenuse. Cosine of theta is adjacent over hypotenuse. But then you're going to change it to inverse trig. Inverse cosine. So you go like this. Inverse cosine of, move this junk over. And notice this equation here on top, that's not solved for theta. Theta's kind of buried in everything. This equation, that's the beauty of inverse trig, is it gets it solved for theta. So theta's alone. You have just the angle when you're done. So that's why putting this in the calculator is handy, because it gives you just the angle. And what did you get for an angle? 67.9? So if we go 67.9, it's pretty much 68. So if that's 68 degrees, then the angle of depression would really be this angle right here, 22. All right. Yes? I get what you're saying. So you're saying you could have changed triangles and done it with, let me use purple or something. This purple triangle here. And if you use that purple triangle there, then you'd be solving for this angle right off the bat. You wouldn't know it. You'd have a theta here. And you could say that's 8,000 and that's 3,000. So sine is opposite over hypotenuse. So inverse sine of 3,000 over 8,000 would have gotten you the 22 also. Yes. Good idea. Okay. So you got a bunch of time. I encourage you to skip a few problems in the packet. There's the last three. I think it's 28, actually more than three. Starting on number 28, skip from there on. Mrs. Richards looked at it more thoroughly and decided that we would be able to guarantee you that you would not need to know things beyond 28 and beyond. Okay? So you can skip the last few problems there. And if you want to do more problems, there are a couple problems that are munched together on number 6. Problem number 6 has got an extra problem in there, and problem number 9 has an extra problem in there. Okay, get to work. If you need more help, come on up and ask. Yes, that's old homework.